division by using the sutra Ekadhikena purvena. This is a specific method of division and is used when denominator contains 9 in its units place. Denominator means divisor. Okay, it's very interesting to learn and practice this method as maximum calculations are done mentally. This division method is used to convert fractions into decimal. So friends, let us first learn algorithm and then practice few examples. Step number 1. Make sure that denominator contains 9 in its units place. And if there are 3, 7 or 1 in the units place, then multiply the fractions by a suitable multiple to get 9 in the units place of divisor, that is denominator. Step number 2. Now you have 9 in the units place of denominator. Now what to do? Step number 2. Calculate Ekadhik, that is one more of denominator, and shift decimal point leftwards by one place. Step number 3. Start division process as explained. Write remainder as a prefix to quotient digit. Prefix is written at the left of quotient digit but at lower level. And step number 4. Stop the process of division when you reach a place from where whole set of quotients will repeat itself. This is the same place where you start the division. See friends, this is best understood while practicing the examples. Let us practice these 3 examples. So let us solve first example, 1 by 19. 1 upon 19. 19 is divisor and 1 is dividend. 19 is denominator and 1 is numerator. So let us see first step. What is first step? Make sure that denominator contains 9 in its units place, and if there are 3, 7 or 1 in the units place, then multiply the fraction by suitable multiple to get 9 in the units place of divisor, that is denominator. See friends, already we have 9 in the units place of denominator. So let us learn step number 2. Now friends, if you have 9 in the units place of denominator, then calculate Ekadhik of denominator. Ekadhik means one more. Ekadhik of denominator and shift decimal point leftwards by one place. See friends, 1 upon 19 is 9 in the units place of denominator. Calculate the Ekadhik of this 19. What is Ekadhik of this 19? What is Ekadhik? Ekadhik is one more. That means add 1 to this 19. See, 1 upon 19 is approximately equal to, nearly equal to, because I added 1 to this 19 and got 20. Ekadhik of 19 is 20. So it is nearly equal to 1 by 20. That means 1 upon 20. Now friends, what to do? Second step, shift decimal point leftwards by one place. Okay, let us shift it. We will shift decimal point leftwards by one place. That means 0.1 in the numerator and in the denominator 2.0. See, we shifted decimal point leftwards by one place. Now, which is, this term is equal to 0.1 by 2. Okay, 0.1 by or upon 2. Now friends, see, third step, start division process as explained. Okay, I will explain it. Write remainder as a prefix to quotient digits. Prefix is written at the left of quotient digits but at lower level. This writing prefix, okay, this writing prefix, we do it in Dvajanka division method. So this division method is preparation for Dvajanka division. So I will write here because we are going to get lots of quotient digits here. 0.1 upon 2, which is equal to now Now let us divide this 0.1 by this 2. So 0 point, see for this, okay, did you get it? 0 point, I have written this decimal point here to represent this, okay. Now divide this 1 by 2. Now dividing this 1 by 2, see, conventionally how do we write? Like this. We are dividing this 1 by 2, but 2 is greater than 1, so cannot divide, so quotient is 0. Quotient is 0. We will write 0 here. Product of 2 and 0 is 0. So 1 minus 0 is 1. That means this 1 is remainder and 0 is quotient. See, understand this very well, friends, because we will write the answer, we will write the quotient in one line. We will not divide like this. This is the basic concept. Quotient is 0 and remainder is 1. Now friends, important point. Write remainder 1 as a prefix to quotient digit. See, this is quotient. See here. This is quotient we have written here. And this is remainder. You are going to write remainder as a prefix to quotient digit. How do we write prefix? See, refer it. Start division process as explained. Write remainder as prefix to quotient digit. Prefix is written at the left of quotient digit but at lower level. Yes, we have written exactly like that. See, this is quotient and write prefix at the left of quotient digit. Yes, but at lower level. See, we have written this remainder at lower level. Okay. Now friends, read this as 10. See, read this as 10. 1 and 0. You don't have to read this as 1 and 0. See, this 1 is remainder. This 0 is quotient. We wrote remainder 1 as a prefix to quotient digit 0. Now read this as 10 and let this 10 be our next dividend. Now divide this 10 by 2. So 10 by 2. Okay, that means 10 divided by 2. So 2 5s are 10. Remainder is 0. So let us write 5 here and remainder 0 as a prefix. Let us write 5 here, quotient digit 5 here, and let us write remainder 0 as a prefix to quotient digit 5. Now friends, read this as 5. Okay, read this as 5 and let this 5, let this 0 5 be your next dividend. Divide this 5, see, divide this 0 5 by 2. Divide this 0 5 by 2. 0 5 means 5. 2 2s are 4. Subtract 4 from 5 and remainder is 1. So write 2. Okay, write quotient digit 2 and write remainder 1 as a prefix to this 2. Now don't read this as 1 and 2 separately. Read this as 12. Read this as 12. See friends, what I am telling you is very much important because this will be used, this concept is going to be used widely in the next topics. Now divide this 12, let this be a dividend. Divide this 12 by divisor 2. 2 6 are 12. Remainder is 0. So write quotient digit 6 and write remainder 0 as a prefix to quotient digit 6. Now read this as 0 6. 0 6 means 6. Now this 6 be next dividend. Now divide this 6 by divisor 2. So 6 by 2. 2 3s are 6. So write quotient digit 3 and write remainder 0 as a prefix to quotient digit 3. Now friends, read this as 3, 0 3. Read this as 0,3 and let this 0,3 be our next dividend. So divide this 0,3, 0,3 means 3, okay, by 2. 2 ones are 2, subtract this 2 from 3, you will get remainder 1. Write quotient digit 1 and write remainder 1 as a prefix to quotient digit 1. Now read this as 11, read this as 11 and not as 1 and 1 separately. Read this as 11 and let this 11 be our next dividend. So divide this by 2, divide 11 by 2, 2 5s are 10, remainder is 1. Write quotient digit 5 here and write remainder as a prefix to quotient digit 5. Now read this as 15 and this 15 is next dividend. 15 divided by 2, 2 7s are 14, okay, remainder is 1. So write quotient digit 7 and write remainder 1 as a prefix to this 7. Now read this as 17 and this 17 is our next dividend. So divide this 17 by 2, 2 8s are 16, remainder is 1. Write 8, write quotient digit 8 and write remainder 1 as a prefix to 8. Now friends, read this as 18 and not 1 and 8 separately. Read this as 18 and this 18 is next dividend. So friends, let me clear it first. Now divide this dividend 18 by 2. 2 9s are 18. Okay, remainder is 0. Write 9 and write remainder 0 as a prefix to 9. Now read this as 9, 0, 9 and let this be our next dividend. So divide this 9 by 2, 2 4s are 8, okay, remainder is 1. Write quotient digit 4 and write remainder 1 as a prefix to 4. Write remainder 1 as a prefix to quotient digit 4. Now read this as 14 and not as 1 and 4 separately. Now this 14 is next dividend and divide this 14 by 2. 2 7s are 14, okay, remainder is 0. So write quotient digit 7 here and write this 0 as a prefix to next digit, quotient digit 7. See, I repeat, write quotient digit 7 here and write remainder 0 as a prefix to quotient digit 7. Now read this as 7 and let this 7 be our next dividend. So divide this 7 by 2. Divide dividend 7 by divisor 2, denominator 2. 2 3s are 6, remainder is 1. So write quotient digit 3 and write remainder 1 as a prefix to quotient digit 3. Now read this as 13 and not as 1 and 3 separately. Let this 13 be our next dividend. So let us divide this 13 by 2. So 2 6s are 12, remainder is 1. Write 6 and write remainder 1 as a prefix to quotient digit 6. Now read this as 16 and this 16 is next dividend. So 16 by 2, that means divided 16 divided by 2. So 2 8 is 16, remainder is 0. Write quotient digit 8 and write 0 as a prefix. Write remainder 0 as a prefix to quotient digit 8. Okay friends, now I am going to clear it. Now let this 0 8, that means 8, be our next dividend. So divide 8 by 2, 2 4s are 8, remainder is 0. So write quotient digit 4 and write remainder 0 as a prefix to 4, quotient digit 4. Now this 404 is our next dividend. Read this as 4. So 4 divided by 2, to 2s are 4, okay, remainder is 0. Write quotient 2 and write remainder 0 as a prefix to quotient digit 2. Now read this as 02, that means 2, and this is our next dividend. So divide this 2 by divisor 2. So quotient will be 1, 2 ones are 2, and remainder is 0. Now friends, watch this digit last quotient carefully. That is 1. That is 1, and this is the same digit, this is the same number from which we started our division. See, 1 divided by 2, and we got these quotients, the series of quotients, this set of quotients. Now if we divide this 1 by 2, then these quotient digits will be repeated, obviously. Okay, see, let us read step number 4. Stop the process of division when you reach a place from where whole set of quotients will repeat itself. This is the same place where you starts division. Yes, correct. See, we will have to stop our division process here, because if we continue dividing, then these quotient digits will get repeated. These quotient digits will be recurred. So let us stop our division process here and write this quotient as a final answer. Let us write final answer 0. See, neglect these prefixes. 0.0526, 0, 5, 2, 6, 3, 1, 5, 7, 8, 9, 4, 7, 3, 6, 8, 4, 2 and 1. See friends, this is our answer. How beautiful, how interesting method is this. You can divide in one line and fast. So let us solve next example. I hope you have understood it. See, read these 4 steps properly once again and write these steps, okay, by pausing the video, and write these steps also. So next example, second example, 2 divided by 29. See, 2 divided by 29. Numerator is 2 and denominator is 29. Having units place digit 9 is first condition, which is satisfied here. So let us calculate the Ekadhik of this 29. Ekadhik of 29 is 30. Now friends, let us shift decimal point leftwards by one place, that is 0.2 and 3.0, correct, which is equal to, this term is equal to 0.2 upon 3. Now friends, let us start division process. 0.2 divided by 3. This is numerator, this is denominator. Now let us start division. First of all, write this 0 point for this. Now divide this 2. Now this example will be solved in one line, friends. I hope that in the last example you have understood the working steps properly. Now in this example, let us solve in one line. So 2 divided by 3. Please focus. 2 divided by 3 cannot divide. So quotient is 0 and remainder is 2. quotient is 0 and remainder is 2. Now read this as 20 and this 20 is our next dividend. Divide this 20 by 3. 3 6 the 18. 3 6 the 18. 20 minus 18. 2. Remainder is 2. Write this 2 as a prefix to quotient digit 6. Now read this as 26 and this is our new dividend. Divide this 26 by divisor 3. 3 8 is 24. 3 8 is 24. 26 minus 24, 2. Write remainder 2 as a prefix to quotient digit 8. Now read this as 28 and not as 2 and 8 separately. Read this as 28. Now divide this 28 by 3. 3 9s are 27. 28 minus 27, 1. Remainder is 1 and that should be written as a prefix to quotient digit 9. Now read this as 19. Read this as 19 and this 19 is next dividend. Divide this 19 by 3. 3 6 the 18. 3 6 the 18. 19 minus 18, 1. Remainder is 1 and write this remainder 1 as a prefix to quotient digit 6. Now read this as 16. 1 and 6. Read this as 16. Divide this 16 by divisor 3. 3 5s are 15. 16 minus 15 is 1. So remainder 1 to be written as a prefix to next quotient digit 5. Now read this as 15. 15 divided by 3. So 3 5s are 15. 3 5s are 15. 15 minus 15 0. Remainder is 0 and to be written as a prefix to next quotient digit 5. Now read this as 0 5, that means 5 and this 5 is next dividend. Now divide this 5 by 3. 3 ones are 3. 5 minus 3, 2. Write this 2, remainder 2 as a prefix to next quotient digit 1. Now read this as 21. Now this 21 is next dividend. Now divide this 21 by divisor 3. 3 7s are 21. 21 minus 21, 0. Remainder is 0. Write remainder 0 as a prefix to next quotient digit 7. Now read this as 7. 0 7 means 7 and this is our next dividend. Divide dividend 7 by divisor 3. 3 2s are 6. 3 2s are 6. 7 minus 6 is 1. Write remainder 1 as a prefix to next quotient digit 2. Now read this as 12. 3 4s are 12. 12 minus 12, 0. Write remainder 0 as a prefix to this 4 and read this as 4. This is new dividend. 4 divided by 3. 3 ones are 3. 4 minus 3 is 1. Now read this as 11. 11 is next dividend. Divide this dividend 11 by divisor 3. 3 3s are 9. 11 minus 9 is 2. 11 minus 9 is 2. Read this as 23. Divide this 23 by 3. 3 7s are 21 and write quotient digit 7. Okay, first write quotient digit 7 and 23 minus 21 is 2. Write the remainder 2 as a prefix to next quotient digit 7. Now read this as 27. 3 9s are 27. 27 minus 27, 0. Write remainder 0 as a prefix to quotient digit 9. Now read this as 9 and divide this 9 by 3. 3 3s are 9. write remainder 0 as a prefix to this 3. Now read this as 3 and divide this 3 by 3. 3 ones are 3. 3 minus 3, 0. Write remainder 0 as a prefix to quotient 1. So 1 cannot be divided by 3. So write 0 and remainder 1. 3 3s are 9. 3 3s are 9. 10 minus 9, 1. Now 3 4s are 12. 3 4s are 12. Write 1. Remainder 1. 3 4s are 12. 14 minus 12, 2. Write this 2. Now 3 8s are 24. 24 minus 24, 0. So write quotient digit 8 and remainder 0. Now divide this 8 by 3. 3 2s are 6. 3 2s are 6. 8 minus 6 is 2. 3 7s are 21. Write remainder 1. 3 5s are 15. Okay, 3 5s are 15. 17 minus 15 is 2. Write this remainder 2 as a prefix to next quotient digit, which is 5. Now read this as 25. Divide this 25 by 3. 3 8s are 24. 25 minus 24, 1. Now read this as 18. See, this 1 is remainder, 8 is quotient. Okay, now read this as 18 and divide this 18 by 3. So 3 6s are 18. 18 minus 18, 0. Now read this as 6 and divide this 6 by 3. 3 2s are 6. 3 2s are 6. 6 minus 6, 0. So friends, it is time to stop the division process here because we have got the quotient 2. And if we divide this 2, then see, this 2 is starting point of this division. 2 divided by 3 and we got these quotients here, quotient digits here. So if we divide this 2, then all these quotient digits will be repeated. So let us stop our division process at this point. Now let us write final answer. See, neglect these prefixes. Okay, so 0.0689351 Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28. We calculated the answer till 28 decimal places. Friends, see the utility of this method. So please write these steps. Let us solve next example. 1 divided by 39. 1 divided by 39. There is 9 in the units place of denominator 39. So let us calculate the Ekadhik of this 39. 1 upon 39 is approximately equal to 1 upon 40. Why this 40? I added 1 to this 39, that means I calculated the Ekadhik of this 39 and wrote 40 as a denominator. Now friends, let us shift decimal point leftwards by one place. 0.1 and 4.0, and this term is equal to 0.1 upon 4. Now let us start the division process considering this term 0.1 upon 4. 0.1 upon 4 is equal to, write 0 point first. Now 1 divided by 4 cannot divide. 4 is greater than 1, so quotient is 0. Okay, quotient is 0 and remainder is 1. Now consider this as 10, read this as 10. 10 is dividend, so 10 divided by 4 is 4 2s are 8. 10 minus 8 is 2, write 2, that means remainder 2 as a prefix to quotient digit 2. Now read this as 22. This 22 is dividend. Now divide this 22 by 4. 4 5s are 20. 22 minus 20 is 2. Now remainder is 2 and write remainder 2 as a prefix to next quotient digit 5. Now read this as 25 and this 25 is next dividend. Divide this 25 by 4. So 4 6 are 24, yes. 4 6 are 24. 25 minus 24 is 1. Now read this as 16. See, this 1 is remainder. We wrote this remainder 1 as a prefix to next quotient digit 6. Now read this as 16. 16 divided by 4. 4 4s are 16. Okay, 16 minus 16, 0. And read this as 4. See, this 0 is remainder and 4 is last quotient digit. Now read this as 4 and divide this 4 by divisor 4. 4 ones are 4. Okay, 4 minus 4, 0. Write remainder 0 as a prefix to this 1. Now friends, I think 1 is starting point of the division. See, 1 divided by 4. Okay, so we started division from here, and if we divide this 1 again, then these quotient digits will get repeated. So let us stop division process here. So answer is 0.02564 and 1. Okay, so let us write the final answer. Neglect these prefixes. 0.02564 and 1. Division by using the sutra Ekadhikena purvena for the denominators which contains 7 in its units place. Okay, see friends, procedure is same, but to use Ekadhikena purvena we need 9 in the units place of denominator, but we have 17, that means its units place contain 7. Okay, now how to get 9 in the units place of this denominator? See, multiply by some suitable multiple. 7 upon 7 is that suitable multiple. By using this multiple, we will get 9 in the units place of denominator. Let us see how. 1 multiplied by 7, 7. And 17 multiplied by 7, 119. Now friends, we have 9 in the units place of denominator. So let us apply Ekadhikena purvena here. Let us calculate the Ekadhik of this denominator. 7 upon 120. Now let us shift decimal point leftwards by one place. That means this term will become 0.7 and 12.0, which is equal to 0.7 by 12. That means upon 12. Now let us divide 0.7 by 12. 0.7 is dividend and 12 is divisor. So 0.7 upon 12, which is equal to 0. So 12 is greater than 7, so cannot divide. So write 0 here. 7, first step is 7 divided by 12, which gives quotient 0 and remainder 7. Correct? See, 12 cannot divide this 7, so quotient is 0. 12, 0, 0, okay, and 7. Okay, in this way we have quotient 0 and remainder 7. So we have written quotient 0 and we will write remainder 7 as a prefix to quotient 0. Now read this as 70. Don't read this as 7 and 0 separately, but read this as 70, and this 70 is our new dividend. Now divide this 70 by 12. 12 5s are 60. 12 5s are 60. 70 minus 60, 10. I have written 5, which is quotient, and I have written 10 as a prefix to quotient 5. This 10 is remainder. See, step number 2. 70 divided by 12 gives us quotient 5 and remainder 10. I have written 5 here and I have written remainder 10 as a prefix to quotient digit 5. Now friends, read this as 105. So step number 3 is 105 divided by 12, which gives us 12 8. 12 8s are 96. Yes. So quotient is 8 and 96 4 5, that is 9. So remainder is 9. 12 8s are 96. 105 minus 96, 9. So I will write quotient 8 here and I will write remainder 9 here as a prefix to quotient digit 8. Now friends, see, read this as 98 and this 98 is dividend now. Let us divide this 98 by 12. So step number 4 is 98 divided by 12, which gives us again 8, quotient 8, and remainder 98 minus 96 is 2. So write quotient 8 and write remainder 2 as a prefix to quotient digit 8. Now read this as 28. Step number 5. Read this as 28 and this 28 is dividend. So divide this dividend 28 by divisor 12. 12 2s are 24. 28 minus 24, remainder is 4. So write quotient 2 and remainder 4 as a prefix to quotient digit 2. Now read this as 42. This 42 is dividend. So 42 divided by 12 gives us 12 3s are 36, that means quotient 3. 42 minus 36 is 6. That means quotient is 3 and remainder is 6. So write quotient 3 and write remainder 6 as a prefix to quotient digit 3. Now read this as 63. Read this as 63 and divide 63 by 12, which gives us 12 5s are 60. 63 minus 60, 3. So write quotient 5 and write remainder 3 as a prefix to quotient digit 5. Now read this as 35. This is 35 now. 35 is dividend. So step number 8, 35 divided by 12, which gives us 12 2s are 24. Quotient is 2. 35 minus 24, 11. So quotient is 2 and remainder is 11. So write quotient digit 2 and write remainder 11 as a prefix to quotient digit 2. Now read this as 112. 112. That means 112. Now 112 is dividend now, divided by 12, which gives us 12 nines are 108. So quotient is 9. 112 minus 108, 4. So quotient is 9 and remainder is 4. So write quotient 9 and remainder 4 as a prefix to quotient digit 9. Step number 10. Now friends, read this 49 as 49 and this 49 is dividend. 49 divided by 12 gives us 12 fours are 48. 49 minus 48, 1. So quotient is 4 and remainder is 1 and should be written as a prefix to quotient digit 4. Now step number 11. Read this as 14, 1, 4, 14. This 14 is dividend now. 14 divided by 12 is 12 ones are 12, 14 minus 12 is 2. So quotient 1 and remainder 2 should be written as a prefix to quotient digit 1. Step number 12. Read this as 21. Divide it by 12. 12 ones are 12. 21 minus 12 is 9. So write quotient 1 and write remainder 9 as a prefix to quotient digit 1. Now read this as 91. Read this as 91 and divide this 91 by 12. 91 divided by 12 gives us 12 6 are 72, 12 7 are 84. 7. 91 minus 84, 6 plus 1 7, that means 7. So quotient is 7 and remainder is 7. So write quotient 7 and remainder 7 as a prefix to quotient digit 7. Now read this 7 7 as 71. Step number 14 is 77 divided by 12 gives us how much? 12 6 are 72. 6. 77 minus 72 is 5. Write quotient 6 and write remainder 5 as a prefix to quotient digit 6. Now read this as 56. Step number 15 is 56 divided by 12 gives us 12 fours are 48, 4, and 56 minus 48, that means 8. So write quotient 4 and remainder 8. How to write? Write quotient digit 4 and write remainder 8 as a prefix to 4. Quotient digit 4. Now read this as 84 and this 84 is dividend. So 84 divided by 12 gives us 12 sevens are 84 and 0. See, 12 sevens are 84, 84 minus 84, 0. So write 7 and write remainder 0 as a prefix to this 7. Now friends, let us stop our division process here because this 7, see, this 7 is the same digit which is at the starting point. That means we started this division by dividing the 7. That means if we divided this 7, then this set of quotient digits will repeat itself. So let us stop our division process. Now let us write answer. 1 by 17 is equal to 0. See, neglect these prefixes, okay? 0 0.05882 3 5 2 9 4 1 1 7 6 4 7. So this is our answer. Second example. 3 upon 27. 3 upon 27. Say friends, to use Ekadhikena purvena division, we need 9 in the units place of denominator, but we have 7 here. So let us multiply this fraction by some suitable multiple. Which is that suitable multiple? 7 upon 7. 3 sevens are 21 and 27 multiplied by 7. How much? 7 sevens are 49. Carry 4. 7 twos are 14 plus 4 18. 27 sevens are 189. We have 9 in the units place of denominator now. Now let us calculate ekadhik of denominator. That means let us add 1 to this 189. So 21 divided by 190. We added 1 to this 189 and we got 190. Okay, this is 9. Now friends, let us shift decimal point leftwards by one place. It will become 2.1 upon 19.0, and this term is equal to 2.1 upon 19. Now let us divide 2.1 by 19. 2.1 divided by 19. Now let us start division process. 0 point for this point. Okay. Now 21 divided by 19. 21 divided by 19. 1. 19 ones are 19. 21 minus 19. 2. See, 21 divided by 19. Quotient is 1. 19 ones are 19. So quotient is 1. And 21 minus 19 is 2. Again 21. So this 21, read this as 21 and divide this 21 by 19 by divisor 19. So 21 divided by 19. Quotient is 1 and remainder is 2. Again 21. So divide this 21 by divisor 19. Again quotient 1 and remainder 2. 21 minus 19 is 2. Again 21. So divide this 21 by 19. Quotient is 1 and remainder is 2. This 1 will recur continuously. So let us write answer, and answer will be 3 by 27. 3 divided by 27 is 0.1111 and so on. Okay. Now friends, let us use the division by using Ekadhikena purvena for the denominators which contains 3 in its units place. Okay, so let us solve first example. 1 upon 13. 1 numerator, 13 denominator. That means 1 is dividend and 13 is divisor. So 1 upon 13. Now friends, to use Ekadhikena purvena division, we need 9 in the units place of denominator. But we have 3. So let us multiply this fraction by some suitable multiple. Got it? If we multiply 1 upon 13 by 3 upon 3, then we get 9 in the units place of denominator. See, which is equal to 3. 13 threes are 39. Now we have 9 in the units place of denominator. Now friends, let us apply Ekadhikena purvena. That means let us calculate Ekadhik of this 39. 3 upon 40. I added 1 to this 39 and I got 40. Now friends, let us shift decimal point leftwards by one place. So this fraction will become 0.3 upon 4.0, and this term is equal to 0.3 upon 4. Now let us divide 0.3 by 4. 0.3 3 by 4. So 0 point. Okay, for this point, divide 3 by 4. Step number 1, divide this 3 by 4. Cannot divide, so quotient is 0 and remainder is 3. So write quotient 0 and remainder 3 as a prefix to quotient 0, quotient digit 0. Now read this as 30. See friends, basically the calculations being used in this division should be mental, oral, because there are easy calculation. To make the calculations easy and to make the method one-liner method, we apply Ekadhikena purvena sutra. See, denominator was much greater, 39, but we reduced it by applying Ekadhikena purvena to this 4. So calculations should be oral, should be mental. So next steps will be done mentally, orally. Okay. So step number 1 was dividing this 3 by 4. Quotient digit is 0, that means quotient is 0 and remainder is 3. We wrote remainder 3 as a prefix to quotient digit 0. Now this is 30. 30 is dividend. So let us divide this 30 by divisor 4. So 4 sevens are 28. 30 minus 28 is 2. So remainder is 2 and write remainder 2 as a prefix to quotient digit 7. Next step, now read this as 27 and divide this 27 by divisor 4. So 4 sevens are 28, 4 6s are 24. That means quotient digit is 6 here. 27 minus 24, 3. Now read this as 36 and divide this 36 by 4. So 4 nines are 36. 4 nines are 36. 36 minus 36, 0. Write remainder 0 as a prefix to 9. Now read this as 9. 9 divided by 4. 4 twos are 8. Write quotient digit 2 and write remainder 1. See, 9 minus 8 is 1. So remainder 1. And we wrote remainder 1 as a prefix to quotient digit 2. Now this is 12. Read this as 12 and this is dividend. So 12 divided by 4 is 3. 12 minus 12, 0. That means remainder is 0. Now see friends, 3 is dividend now. If you divide the dividend 3 by 4, then the set of these quotient digits will be repeated. See, we started this division by dividing 3. So 0, 7, 6, 9, 2, 3 will be repeated again. So let us stop this division here at this point, at this digit. So let us stop the division and write final answer. So final answer is 1 by 13, 1 upon 13 is equal to 0 point, neglect these prefixes, okay, 0 0.0, 7, 6, 9, 2 and 3. 0.07692 okay. Second example, 3 upon 43. 3 upon 43. Now we need 9 in the units place of denominator. So let us multiply this fraction by some suitable multiple, which is 3 upon 3, and we get 3 3s are 9 and 43 multiplied by 3 means 3 3s are 9 and 3 4s are 12. 129. Yes, now we have 9 in the units place of denominator. Now let us calculate Ekadhik of 129. So 9 upon 130. I added 1 to this 129 and got 130. Adding 1 to any number is to calculate Ekadhik of that number. Now friends, consider this fraction. Let us shift decimal point leftwards by one place. It becomes 0.9 and 13.0. This term is equal to 0.9 upon 13. Now let us divide 0.9 by 13. Okay, so let us divide 0.9 upon 13. So let us start division. 0. Now divide 9 by 13. Cannot divide because 13 is greater than 9. So write 0 again. And write remainder 9 as a prefix to this quotient 0. See, understand this. 9 and 13. 13 cannot divide 9 because 13 is greater than 9. So quotient is 0. 13 0 0 and remainder 9. So I wrote quotient digit 0 and I wrote 9 remainder 9 as a prefix to 0. Now read this as 19. Read this as 90. Now let us divide this 90. This 90 is dividend. Divide this 90 by 13. So 13 6 are 78. That means 13 6. So 90 minus 13 6 are 78, which is 12. 90 minus 78 is 12, and write this 12 remainder 12 as a prefix to quotient digit 6. Now read this as 126. Read these three digits 1, 2 and 6 as 126. This is dividend, and divide this dividend 126 by divisor 13. So 13 8s are 104, 13 9s are 117. So 13 9s are 117. 126 minus 117. 9. So I wrote remainder 9 as a prefix to quotient digit 9. Now read this as 99, and this is our dividend. Okay, so divide this 99 by 13. So 13 sevens are 91. Yes, 13 sevens are 91. 99 minus 91 is 8. So write remainder 8 as a prefix to quotient digit 7. Now read this as 87. Read these two digits 8 and 7 as 87, and this 87 is dividend. Divide this 87 by 13. So 13 6 are 78. Yes, 13 6 are 78. 87 minus 78, 9. So I wrote remainder 9 as a prefix to next quotient digit 6. Read this as 96, and this 96 is dividend. So divide this 96 by 13. 96, that means 13 sevens are 91. 13 sevens are 91. 96 minus 91, 5. So this 5 is remainder and written as a prefix to quotient digit 7. Now read this as 57. 57 divided by 13. 13 fours are 52. Yes, 13 fours are 52. 57 minus 52, 5. Read this as 54, and this 54 is dividend. So divide this 54 by 13. Again 13 fours are 52. 54 minus 52, 2. Write remainder 2 as a prefix to quotient digit 4. Now read this as 24 and divide it by 13. 13 ones are 13. 24 minus 13 is 11. Okay, now read these three digits 1, 1 and 1 as 111, and divide this 111 by 13. 13 8s are 104. 13 8s are 104. 111 minus 104. 6 plus 1 7. Yes. Remainder is 7. So 7 remainder 7 is written as a prefix to next quotient digit 8. So read this as 78. So 13 6s are 78. 78 minus 78, 0. Now read this as 6. 13 cannot divide 6 because 13 is greater than 6. So write quotient 0 and remainder 6. Now read this as 60. 60 divided by 13. So 13 4 is 52. 60 minus 52 is 8. Okay. Now read this as 84 and divide this 84 by divisor 13. 13 6 is 78. Yes. 84 minus 78, 6. 6 is quotient digit and this 6 is remainder. So this is written as prefix to quotient digit 6. Divide 66 by 13. 13 5s are 65. Write remainder 1. 13 5s are 65. 66 minus 65 is 1. So write remainder as a prefix to quotient digit 5. Now read this as 15. Divide it by 13. 13 ones are 13. 15 minus 13 is 2. Now divide this 21 by 13. 13 ones are 13. Okay, 21 minus 13 is 8. Now divide this 81 by 13. 13 6 78. 81 minus 78. 81 minus 78 is 3. So remainder 3 is written as a prefix to next quotient digit 6. Now read this as 36. Divide 36 by 13. 13 2s are 26. 36 minus 26, 10. Now read these 3 digits 1, 0 and 2 as 102 and divide this 102 by 13. So 13 sevens are 13 sevens are 91. 102 minus 91. Okay, 11. Correct. 102 minus 91 is 11. 11 is remainder and write remainder as a prefix to next quotient digit 7. Now read these 3 digits 1, 1 and 7 as 117. So 13 nines are 117. 117 minus 117 is 0. So write 0 as a prefix to quotient digit 9. Now read this as 9. But friends, we will have to stop division process here. If you divide this 9, then all these quotient digits will be repeated because we started the division by dividing 9 by 13. So all the quotient digits will be repeated. So let us stop division process and write final answer. So 3 upon 43 is equal to 0.069 76 744 186046511627 Okay, so this is answer. Third example, 5 upon 23. 5 upon 23. We need 9 in the units place of denominator, in the units place of divisor, but we have 3. So let us multiply this fraction by suitable multiple, which is 3 by 3. 3 upon 3, which gives us 15 upon 69. 15 upon 69. Now we have 9 in the units place of denominator. So let us calculate Ekadhik of denominator, that means Ekadhik of 69. 15 upon 70. Correct? We added 1 to this 69. That means we calculated Ekadhik of 69. Ekadhik means one more. So we have 70. Now friends, shift decimal point leftwards by one place. 1.5 and 7.0, and this term is equal to 1.5 upon 7. So friends, let us divide 1.5 by 7. So 0. Now divide 15 by 7. 7 twos are 14. 15 minus 14 is 1. Write 1 as a prefix to quotient digit 2. 1 is remainder. 7 twos are 14. 7 twos are 14. 15 minus 14, 1. I wrote remainder 1 as a prefix to quotient digit 2. Now read this as 12 and divide this 12 by 7. 7 ones are 7. 12 minus 7 is 5. Now divide 51. Read this as 51 and divide this 51 by 7. So 7 sevens are 49. 7 sevens are 49. 51 minus 49, 2. Read this as 27 and divide 27 by 7. So 7 threes are 21. 27 minus 21 is 6. 6 is remainder and is written as a prefix to quotient digit 3. Now read this as 63. 63 divided by 7, 9. 63 minus 63, 0. Now read this as 9 and divide by 7. So 7 ones are 9 minus 7, 2. Divide this 21 by 7. 7 threes are 21. Write 0. Now divide this 3 by 7. 7 is greater than 3. So quotient is 0 and remainder is 3. Now divide this 30 by 7. 7 fours are 28. 30 minus 28, 2. Now to this 24, divide by 7. 7 threes are 21. 24 minus 21, 3. Now read this as 33 and divide it by 7. 7 fours are 28. 33 minus 28, 5. 5 is remainder and written as a prefix to next quotient digit 4. Next quotient digit means last quotient digit. Now read this as 54 and divide 54 by 7. 7 sevens are 49. 54 minus 49, 5. Okay, now divide this 57 by 7. 7 eights are 56. Okay, 57 minus 56, 1. Divide 18 by 7. 7 twos are 14. 18 minus 14, 4. Divide 42 by 7. 7 sixes are 42. Remainder 0. Now divide this 6 by 7. Cannot divide. So quotient is 0 and remainder is 6. Now read this as 60 and divide this 60 by 7. 7 eights are 56. 60 minus 56, 4. Divide 48 by 7. 7 6 are 42. 7 6 are 42. 48 minus 42, 6. Divide this 66 by 7. 7 nines are 63. 66 minus 63 is 3. 66 minus 63 is 3. Remainder 3. Now divide this 39. See, these two digits 3 and 9. 39. Divide this 39 by 7. So 7 5, 7 5s are 35. 39 minus 35, 4. Now divide this 45 by 7. 7 6 are 42. 45 minus 42, 3. Divide 36 by 7, 5. Divide this 36 by 7. 7 5s are 35. So I have written 5, quotient digit 5. 36 minus 35 is 1. Okay, now friends, let us stop division process here to this 5, quotient digit 5, because if we divide this 5, that means see, dividend is 15, quotient digit 5, and remainder 1 is written as a prefix to quotient digit 5. See, this is 15. This 15 is dividend, and if we divide this 15 by divisor 7, then all these quotient digits will be repeated after this 5. So we will have to stop division process here and write final answer. 5 upon 23 is equal to 0. See, neglect these prefixes. Okay, 0.21739 3043478260869565. Okay, this is the answer. Now friends, let us study this division method for the denominators, for the divisors, which contains 1 in its units place. For example, 1 upon 21. Okay, 1 upon 21. We need 9 in the units place of denominator to apply this division method. So let us multiply 1 upon 21 by some suitable multiple, which is 9, which is equal to 9 by 9, 189. So 9 upon 189. Now we have 9 in the units place. So let us calculate the Ekadhik of 189. Okay, 9 upon 190. Now shift decimal point leftwards by 1 place, which becomes 0.9 and 19.0, and this term is equal to 0.9 upon 90. Now friends, you will observe that there's not much difference between this original divisor and this new divisor. This new divisor, what we have calculated by applying Ekadhikena Purvena Sutra to this denominator 21. So it will not help us in faster and easier calculations. Therefore, we will not apply this division method when we have 1 in the units place of denominator. Now, when there is 1 in the units place of denominator, then we can use Ekanyunena Purvena. That means if it is 1 upon 21, then we reduce this 21 by 1. That means application of Ekanyunena Purvena, approximately equal to 1 upon 20. Then we drop this 0 and okay, write like this, 0.1 divided by 2. But while doing this division, except first few steps, rest of the other steps are exactly similar to Dhwajanka division steps. Dhwajanka division, which will be explained in detail later. So friends, one thing is sure, that we will not apply Ekadhikena Purvena division method when denominator contains 1 in the units place. Okay,